Hi, good evening, students. Now we discuss about the mesomeric effect in GOC, in general organic chemistry. Now we discuss about the GOC, general organic chemistry. Now we discuss about the mesomeric effect. Mesomeric effect or resonance. Now we discuss about mesomeric effect or resonance. Resonance. What is mesomeric effect? Some important points you have to remember. First, mesomeric it operates through pi bond. It is also permanent effect. Third point, complete charges will form. Fourth one, distance independent. This does not depend upon distance. This is distance input. This is distance independent. These are the 4 points we have to remember. It is operates through pi bond, but in case of inductive effect, it operates through sigma bond. This is also permanent effect. Complete charge development is formed. Distance, this is independent. Next, in mesomeric effect, how it operates. This is also 2 types of mesomeric effect. One is plus M effect, another one is minus M effect. What is plus M effect? What is minus effect? First atom contain lone pair, then it shows the plus M effect. If first atom having pi bond, this is minus M effect. First atom having lone pair, that is plus M effect. First atom having pi bond, that is minus M effect. For example, if you take OH, NH2, O C double bond OCH3, OR, alkyl, O minus C double bond C, etc. These are some of the plus M effect. In case of minus M, C double bond O, first atom contain pi bond. Next, C double bond O, CH3, S double bond O, CH3. In case of C double bond O, NH2. Like this, some of the examples to show the plus M effect and minus M effect. If you take plus M effect, for example, if you take this is the benzene having NH2, we see how it operates. If it is having lone pair of electrons, it lone pair donate to this, lone pair converted to bond pair shifted to lone pair. If it is conjugation, this is having negative charge, this is plus NH2, this will converted to lone pair is bond pair is converted to lone pair. Next, what we will see, this is double bond, this is negative charge, this is NH2 plus, this bond pair is converted, lone pair is converted to bond pair shifted to lone pair. Okay, to draw this one negative charge, this is NH2 plus, this lone pair converted to bond pair, this is bond pair converted shifted to nitrogen atom. This is the resonance structure of plus M effect. If you take minus M effect, for example, this case also, NO2 also, if you take in this case N double bond O minus, what will happen? This double bond is converted to lone bond pair is converted to bond pair. Like this will happen or not? Yes. This bond pair is converted to lone pair. In case of nitrogen, what will happen? Here we get positive charge, then this one, N double O minus, then O minus. This is the double bond. Next we have to see what is this bond pair is lone bond pair is converted to bond pair. Here we get positive charge, then these two are O minus. Next we have to see this bond pair is converted to bond pair. Here we get positive charge, then here O minus, then this bond pair is shifted to here, then we get bond pair and double bond O minus. To congested, have to congested. In this case, for example, if you take engineering group, these are the ortho positions, this is the meta positions, this is the para position. Here you see where we will get negative charge in ortho and para position, we get the negative charge. Here where we will get the positive charge? Ortho and para and ortho positions only we will get the positive charge. It means this mesomeric effect does not depend upon the effect on the meta position. It will only operate through ortho and para. It will affect only ortho and para. This point you have to remember. Mesomeric effect does not affect on meta position. You have to remember this one. This is one of the very, very important point. You have to remember. This is the mesomeric effect. Next we have to discuss that. Next we have to discuss some of the important points. Number one, mesomeric effect does not affect on meta position. This is very, very important. Next, second point, less m is greater than minus I. In case of OR and OH, NH2, like this. In this is minus I group as well as plus M. Next, third one, less m is less than minus I in case of halogens. Fourth one, OH availability of lone pair is greater than O, C double bond O, CH3, because this is involved in the resonance. Next, fifth point, less m due to lone pair is greater than alkyl. For example, OH is greater than alkyl. These are some important points you have to remember in the case of mesomeric effect. Next, one by one. Next, one of the two important concept. What is in these applications we have to see stability of the carbocation, carbanion, free radical. That is there. One of the application in this mesomeric effect. Next, we have to discuss important concept, and also I will give some 2-3 examples to compare the stability of the carboxylic acids. First, we have to discuss about the ortho effect. What is ortho effect? Based on this only, application is ortho substituted benzyl carboxylic acid is more acidic compared to meta and para. This is very important. Discuss. First, you have to take this is benzoic acid. If you take this one, what is ortho effect? If you put a G group, bulky group, take this one. If you what will happen in this case? If any carboxylic acid, have to find out the acidity of the carboxylic acid, that depends upon the stability of the carboxylate ion. If it is carboxylate ion is more stable, then this is more acidic. Based on that, in this case, if it is ortho position bulky group is present, what will happen? Complete this plane will be changed. This is one plane, this is another plane. In this case, what will happen? This is involved in the resonance, and also from this benzene also it will compete with this conjugation. But in this case, what will happen? If these two planes are changed, that's why from this resonance is completely stopped due to this bulkiness, this steric hindrance, these two planes are changed. Only this carboxylate ion will stabilize the negative charge, will stabilize this carboxylic acid. That's why this is more stable. More stable carboxylate ion will having more acidic. This is less acidic compared to this. First of all, we have to discuss what is ortho effect. Ortho effect is ortho substituted benzyl carboxylic acid is more acidic compared to meta and para positions. If you take two acidic benzoic acids, one is ortho substituted, one is not ortho substituted. If these two acids, the stability of these two acids, acidity of these two acids depends upon their corresponding conjugate base carboxylate ion stability. If it is more carboxylate ion stable is more, then that acid is more acidic. If in case of this one, there is no bulky group, these two are in the same plane, this will involve in the conjugation, and also from the computation from benzene also it will have in the conjugation. If it is having less stable, if it is due to this bulkiness, it will change this plane. These two are different planes, that's why it stops conjugation from benzene. It only this negative charge will participate in the conjugation. That's why this is more stable than compared to carboxylic acid. That's why this is having more stable, it is having more acidic. This is the main concept of the ortho substituted carboxylic acid is more acidic compared to meta and para. Ortho effect is not affecting groups. You remember this one. Ortho effect not affected in case of hydrogen, in case of NH2, in case of OH and halogen. OH, NH2, halogen. These are not showing any, and Cn. That's hydrogen. These are not affect the ortho position. If you take, for example, one of the compare the acidic strength of the 2,3 carboxylic acids. Take it. If you take, for example, ortho methyl benzoic acid, meta, and if you take para positions of this methyl group, ortho and meta and para. If you take NO2, if you take, for example, NO2, if you take para positions of NO2, please compare the stability of these three carboxylic acids, ortho, meta and para. First of all, we have to, in this case, ortho is more compared to meta and para, due to ortho effect. Remaining two are, this is having, meta position does not affect the mesomeric effect. This is having plus I and plus M, para positions. Compare the acidic strength. Acidic strength is directly proportional to minus M and minus I, inversely proportional to plus M and plus I. Plus Mi, due to plus Mi plus F, this is less acidic compared to meta position. That's why para is less than this. If in case of ortho, ortho is always more because due to ortho effect. If you consider, this is minus I, this is minus M and minus I. This is para and meta. Due to, it is directly proportional to minus I and minus I. That's why this is due to more minus M and minus I. NO2 group is directly proportional to minus M acidic strength. That's why this is having para is more greater than meta. This is the compare the acidic strength of the tomato. This is the ortho effect of the carboxylic acids in case of mesomeric effect. One of the application you have to see. Next, one more application. Third one is compare the basicity of the basic strength of aromatic amines. Basic strength of aromatic amines. This is also one of the important concept we have to discuss. What is aromatic amines? If you take the concept is called steric inhibition, SIR. This is known as steric inhibition of resonance. Steric inhibition of resonance. What is steric inhibition of resonance? How the basic strength of the aromatic amines we have to compare. This is one of the important concepts. First, it operates only secondary and tertiary amines. If you take, for example, if you take this amine, dimethyl amine, how it operates is important. If you compare the basicity, first of all, if you having depends upon the availability of lone pair of electrons. Lone pair of electrons towards H plus ion. If this lone pair of electrons is more available to donate H plus ions, it is more basic. If it is less available, it is less basic. Simple concept. Based on that only, we can compare the acidic strength of the aromatic amines. If it is lone pair electrons is more available, then it is more basic. It is less available, it is less basic. What will happen in this case? In case of dimethylamine, due to this bulky group, it will having lone pair. Due to bulkiness, this will change this plane. It is easily available to attract this H plus ions. It will form dimethylamine more stable. That's why this acidic, this basicity is more basic. this basic strength, this is basic, is more basic, ortho substituted. Due to steric hindrance, due to dimethyl ortho substituted dimethyl aniline, due to steric hindrance, this it will change this plane benzene ring from this one. It will not donate electrons towards the benzene ring. It is easily available to attract this H plus ions. Then it will form H, more stable ion. That's why this is more basic compared to other substituted ions, beta and para positions. It will operate only secondary and tertiary amines. Here, this lone pair is steric inheritance to participate in the resonance. That's why this is called as steric inheritance in resonance. If you take, for example, one or two example, to take basicity and dimethyl